Good morning, everyone. Welcome to the second video on circular motion. Well, yesterday we had seen the first video, and today, and I think by afternoon, by 3:30 p.m., I think you'll be able to see the solution for the first video. Okay, so today at 7 p.m., this video can be seen. Okay, let me continue without wasting my time further. My name is Ratankar Rao, and I teach physics in international school. And if you want to know more about me, you can just log into this website, go through this, and you can also observe the several videos I have posted so far. I think the number is now crossing more than 200. With all your cooperation and the kind of help in the sense, the way how you people shared has really helped me out to do more number of videos. Thank you for all your appreciations. Now let me continue with the videos. Just a moment. It's not moving at all. Okay, it's here. Okay, the first question here reads like this. A motorcycle is cornering on a curved racetrack. So you have a motorcycle which has been cornering like this. Which combination of the changes of the banking angle theta, change angle theta, and the coefficient of friction mu between the tires in the road will allow the motorcyclist to travel around the corner at greater speed for what angle of theta and mu? It means if you increase the value of angle theta and decrease the value of mu, will really be able to travel faster. Or you need to increase both of them, or you decrease one of them and then increase the other one. So which combination will help you out? If you want to answer this, then you should know about circular motion. What kind of circular motion? The clue here is, you see, the circular motion, which is happening on a ramp. Think about it, and you will be able to do it. Right. Now let me move on to the next one. Right over, it works like this. Okay. Satellite X is in orbit around the Earth. The satellite, an identical satellite Y is in a higher orbit, which is correct for total energy and kinetic energy of the satellite Y compared with the satellite X. So what are you going to compare? Total energy and kinetic energy, right? What is kinetic energy? Kinetic energy, you can calculate it using which rule? Using your orbital velocity. Okay, so you can determine that potential energy. You can determine by, what is the formula. I'm not going to reveal it. So based on this, you can find out what is the total energy and kinetic energy of the satellite. So think about it. Try to write it across. Take two different random values. One could be the distance r, the other could be something like distance 2r, and then find out how does it differ. Next. Just a minute. Right. The escape speed of a planet of radius r is v escape. A satellite orbits a planet at distance r from the surface of the planet. What is the orbital speed of the satellite? Which means what? So initially, this is the Earth. Okay, let us say it is at the Earth, or I don't have a pen with me to write. So just bear with me. Or maybe I can take up something here. Just give me a moment. Let me see whether I have the pens available. Oh my God, I have opened it in a different way. Okay. So may not be possible. Okay. A satellite orbits a planet at a distance r from the surface of the Earth. So therefore, from the center, it is 2r, right? 2r. So therefore, what is the orbital speed of the satellite? So you know how to write the orbital speed. Orbital speed velocity. What is the formula? You can, just now I told you about it, which is nothing but root of gm by r. Okay. So think about it and then attempt it. And you also know what is the expression for v escape. So plug in that value and you will get the correct answer. Next. The gravitational potential is V at a distance r from the surface of a spherical planet of radius r and uniform density. What is the gravitational potential at a distance 2r above the surface of the planet? What is the gravitational potential at a distance 2r above the planet? So this is the planet and this is the point over here. So you need to find out what is the gravitational potential at this point. Okay. So this also you can do it. The gravitational potential, if you want, the formula is V equal to Gm divided by R. Okay, so this is your gravitational potential. Then, next one. Mass M is attached to one end of a string. The string is passed through a hollow tube, and mass M is attached to the other end. The friction between the tube and the string is negligible. Wow, great. Mass M travels at higher speed at a constant speed v in a horizontal circle of radius r. What is the mass M? Now, as this starts rotating with a constant speed, then it's a horizontal circular motion. Then what weight should be given here so that this constantly rotates on a horizontal circular motion? This is what you need to answer. Okay. So the answer is very, very nearby to you. Think about it. Then, seventh problem. A child stands on a horizontal rotating platform that is rotating at a constant angular speed. Okay. The centripetal force on side is provided by, what is centripetal force provided by? You can think about it. Okay. I'm not going to do this one. Very, very easy question. Then, an object moves in a circle of constant radius. Values of the centripetal force F are different are measured for different values of angular velocity. Centripetal force and angular velocity. Which formula? Think about it. Okay. And a graph is plotted on the y-axis. Omega on the y-axis. Which quantity plotted on the y-axis? You use a straight line graph. What is he plotting here? Omega. Okay. He is asking you to find out which of these quantities will give you a straight line graph. So the entire question is rotated or revolved around which one? Around the dependence of omega on F. If you know that, everything is fine. Okay, next. A mass at the end of a string is moving in a horizontal circle at constant speed. The string makes an angle theta to the vertical. Okay. What is the magnitude of the acceleration of the mass? Now it moves like this. What is the magnitude of the acceleration of the mass? So first draw a free body diagram and then understand how to find the acceleration. Very easy. Right. Then. Right. A ball is released from a rest at a point P along a wire as shown. Just a minute. The wire loops around and forms a vertical circle of diameter 40 centimeters. And then at point Q, the bead has a speed of 1.4 meter per second. So it starts from here, it keeps on going like this, and finally reaches this point. And the velocity at the point is given. Air resistance of friction of the wire are negligible. What is the height from which the bead is released? Wow. So you need to find out what is the height from here. Which equation will you use? You have to use the two methods, kinematic method, or maybe you can use the energy method. The easiest method is the energy method. Try using it. Conservation of energy. Then, where is it? Yeah, cursor. Right. The change in gravitational potential energy of an object of mass m when moving through a height delta h near the surface of the earth, near the surface. So this equation is okay, mg h or mg delta h. Which equation is needed as part of the derivation of this expression? Nice. Okay, think about it. Many of you may not get this, but still, you can always try understanding how to get this. Okay, thank you, friends. I think that's the last slide here. Yeah, thank you, friends, for watching this so-called video for this much long time. And we'll definitely see to it that solutions are available tomorrow. Do like, share, and subscribe to my channel for more updates. Thank you.